Imagine you ship a feature on Friday that depends on a frontier model, and by Monday morning, the interesting question isn't latency, price, or even model quality. It's whether the government and the vendor still agree that you are allowed to use it. The Anthropic Fable and Mythos story is there this morning. Axios and The Verge both have fresh reporting on the shutdown and the White House reaction, and I want to set the altitude clearly. This is a follow-up to the weekend story, not a second full retelling of it. The new part is the political post-mortem. Axios says officials were frustrated by how Anthropic handled communication around access. The Verge points at the China access concern and the White House pressure, and the practical question for a builder is pretty plain. If model access can change because of a policy fight you don't control, what exactly did you promise your users?
And that promise is usually written in product language, not procurement language. The feature says it summarizes the contract, reviews the pull request, drafts the policy memo, whatever. It doesn't say, this works unless our upstream model gets caught in a fight between export controls, vendor risk, and a department no one on the product team has ever talked to.
Right. The Forbes continuity plan piece is analysis, not the primary source for what happened. But it gets to the operator question. If a model can disappear overnight, continuity planning can't mean a slide that says multi-provider strategy. It has to be tested product behavior. What happens to a saved workflow? What does the user see? Does the system stop, degrade to a weaker model, queue the job, or ask for a human review?
That also changes how you read the lobbying detail. The tweet from Toucan, the @distribution@ account in the source list, describes Anthropic staff and lobbying effort in Washington. I don't want to infer motives past the source, but the mechanism is legible. A model lab that sells access to high-value customers now has to operate in the same room as export policy. That means the sales dependency has a government relations dependency attached to it.
And the procurement people will ask different questions after this. Yesterday was Sunday, and we talked about fallback routing as something engineers should build because APIs fail. Today pushes that into a contract question. A buyer can ask, show me the fallback path for government access changes. Show me which model families are allowed in which jurisdictions. Show me the audit log for a job that crossed from one provider to another. I don't think every buyer will ask that on Tuesday, but the question now has a concrete story behind it.
There's a temptation to make this all about Anthropic's judgment. Some of that is fair, especially if the communication was as messy as the reporting suggests. But if you're the downstream team, the more useful answer is to remove the vendor's drama from your incident model. Assume access can change for reasons that aren't bugs, then design the user-visible behavior.
That is the Monday version of the story. The model may be excellent. The vendor may be acting under constraints. The government may have legitimate concerns. None of that changes the operator sentence. If your product depends on a model you can't guarantee access to, the fallback path isn't a nice extra. It's part of the product claim. The best agent research item today is a paper called When Errors Become Narratives. It studies a long-running personal assistant agent that has been in production since March. The system runs about 40 scheduled jobs, uses 8 large language model providers, and has a tool governance proxy, plus a memory plane. Over 8 weeks, the author documents 22 incidents and names the failure class fail plausible. That's the useful phrase from the paper. The system doesn't just fail silently. It turns an internal error into fluent, plausible output.
That is nastier than a normal outage. A normal outage gives you nothing, or it gives you an error. A fail plausible agent gives you a sentence you can believe. It turns observability into a social problem because the first detector is often the human noticing that the answer feels thematically wrong.
The paper's example is almost painfully concrete. A Unicode surrogate in scraped content caused a JSON write to fail. An adapter returned a bad request. Diagnostics went to standard output, and a downstream command substitution captured that error text as if it were signal. Then the reduction step saw error vocabulary in its context and produced a confident analysis of a fabricated Hugging Face platform crisis. The author's line is that the error had not disappeared, it had been narrated.
The small engineering detail there matters. Standard output versus standard error decides whether the next model call receives data or receives a failed tool's diary. That is the kind of boundary agents make expensive because every downstream step is capable of making the wrong input sound coherent.
The same paper reports that about 70% of the silent failures were caught by human observation of the user-visible output, not by unit tests, health checks, or governance audits. And the governance layer had a 0% prevention rate in a retrospective audit of 15 incidents, but an 87% regression blocking rate after the incidents were understood. I like that distinction. Audits didn't predict the failure. They became machinery for making the same failure harder to repeat.
That matches how mature incident systems usually work. You don't get a magical rule that knows next week's weird coupling. You get a post-mortem that names the mechanism, and then you turn the mechanism into a scanner, a contract test, a state convergence check, or a deployment rule. For agents, the new wrinkle is that the mechanism often includes language generation as an amplifier.
The second paper in the same cluster tests tool-deference. It gives a React-style agent access to a frozen graph neural network as a tool and asks whether the agent uses the tool as evidence or simply obeys it. On the Qwen 2.5 family, once the model can call the tool, its answer agrees with the raw graph neural network 97.6 to 99.2% of the time. The paper calls that a parrot, and the important result is that larger backbones didn't remove the deference.
That cuts against a lot of casual tool agent optimism. People say, give the agent a specialized predictor and it will decide when to trust it. This paper says, in this setup, no. The agent mostly inherits the predictor's answer, and when another option became better in a high homofolly setting, the agent still deferred to the graph tool, so selective invocation has to be engineered. It doesn't reliably appear because the backbone got bigger.
Then Minim gives the privacy version of the same runtime argument. Modern UI agents often send rich, structured observations, like accessibility trees, to a remote model. The paper's claim is that this can leak task-irrelevant context, authentication codes, private notifications, unrelated tabs, and background app state. Minim puts a trusted local broker in front of the model. It scores each UI element for sensitivity and task necessity, then keeps, abstracts, or removes it before disclosure.
And the numbers are practical enough to mention. On their Web Arena-derived test set, Minimic cask critical interactive elements at about 99.3%. It keeps task-critical context at about 94.9% and reduces task-irrelevant sensitive leakage to about 10.1% of the full observation baseline. I wouldn't treat one paper as the final privacy answer, but the architecture is the interesting part. Don't ask the remote agent to be polite with secrets it never needed.
There are two more papers in the cluster that reinforce the same operating picture. Git of Thoughts stores an agent's reasoning tree as a Git repository. Every scored thought is a commit. Scores live as notes, outcomes live as tags, and retrieval uses git log over the agent's own history. The authors hedge the accuracy claim. Memory didn't reliably help on novel problems. The case for Git is that it gives you auditability, provenance, diffs, replay, and merging at accuracy parity.
That negative result is the reason I trust the paper more than I would if it only said, Git makes agents smarter. It says Git makes the reasoning process reviewable. That's a different claim, and for production agents, it may be the more valuable one. If an agent makes a consequential decision, you may care less about whether memory made it clever, and more about whether you can replay the branch that led there.
And SevraBench gives the code review version. It builds malicious pull requests by reversing real vulnerability fixes, then wraps those diffs in 15 social engineering styles. In their evaluation, frontier closed models refused most malicious PRs, while open-weight and weaker closed models were much more variable. The caution isn't just model quality, it is that the attacker controls both the code diff and the story around the diff.
Which is exactly how code review works in the world. A pull request isn't a naked diff. It has a title, a rationale, maybe a claim that tests passed, maybe a claim that someone approved it earlier. A review agent that reads the narrative as evidence has to separate persuasive context from code evidence. That's an evaluation surface we need because agentic coding tools are already entering the merge path.
So the agent segment today isn't more agents are coming. It is more specific than that. If agents are going to run for days, call tools, observe screens, review pull requests, and remember their own past work, the runtime has to preserve causes and minimize observations. It also has to separate tool evidence from tool authority and make reasoning reviewable after the fact. Prompt design is still there, but it is no longer enough of the system to carry the trust claim. The policy cluster today is strongest where it has primary documents. The UK Department for Science, Innovation and Technology published a progress statement letter to Ofcom, and Japan's digital agency posted version 2 of its guideline for government procurement and use of generative AI. These aren't grand AI law moments. They are instructions moving through agencies and regulators.
That matters because implementation is where policy starts touching software. A regulator letter becomes a reporting requirement, a risk assessment, an age assurance interface, a content moderation process, or a procurement checklist. A government guideline becomes model selection criteria and data handling language. It also becomes vendor review and a reason someone asks whether your agent can run in a restricted environment.
TechMeme also points to the UK debate over a social media ban for under 16s. The caution from the agenda is right. That is broader platform policy, not an AI-specific rule. But in practice, the enforcement work overlaps with AI-adjacent systems. Age estimation, account controls, recommendation limits, complaint handling, and moderation review. Even if the statute is about children and platforms, the implementation will pull on machine learning systems and human operations.
And the Forbes military command piece should stay in its lane as commentary. It argues that a dedicated military AI command could backfire if it centralizes too much and slows adoption in the actual units that need the tools. I don't want to present that as an enacted change, but it is a useful warning about org charts. When an institution creates a home for AI, it may also create a queue everyone has to stand in.
That connects back to procurement without needing a big theory. Agencies don't adopt AI in the abstract. They buy systems, approve vendors, define acceptable data flows, assign responsibility, and decide which office can say yes. That is why the UK and Japan documents are more important than the average speech about AI competitiveness. They are closer to the forms a team will actually have to fill out.
And if you're selling into that world, the technical answer has to be legible to non-technical governance. Can you say where the data goes? Can you run a local model for sensitive work? Can you log which model made which recommendation? Can you explain what happens when a provider is unavailable because of policy rather than downtime? Those questions now sit next to model quality.
Under the policy layer, open models and domestic compute keep moving. TechMeme has the Enflame item. The Chinese AI chipmaker has Shanghai IPO approval. Rest of World has an interview with Tiezhen Wang on China's open-source AI strategy. And 2-minute papers covered Nvidia's open-weight model release, though that one is secondary, and I don't want to quote specs from it without a primary model card in front of us.
The practical link is dependency planning. If access to a frontier API can become unstable, then open weights and local hardware aren't just ideological preferences, they are fallback inventory. Maybe the fallback is worse, maybe it is slower, maybe it only covers a narrow workflow, but if you can run it, measure it, and document the degradation, it changes your risk posture.
The Reddit local LLF post is useful only as a small watch detail. A user says token speed doubled and key value cache memory fell for Quen 27 billion on an RTX 3090. It is a screenshot, not a benchmark, but it points at the kind of thing that changes local viability, fewer gigabytes needed, and more tokens per second on hardware someone already owns.
And the chip side matters because local availability isn't only about model licenses. It is about whether enough organizations can buy or rent the accelerators to run the model at the workload they need. Enflame's IPO approval is a finance item, but it sits on that supply question. Domestic chips, domestic customers, and a market that keeps trying to reduce dependence on US export-controlled parts.
Rest of World's interview gives the distribution side of that. China has reasons to push open-source AI that aren't identical to the reasons a Western developer likes open weights. Open distribution can spread capability, help set defaults, and make it easier for local companies to enter markets outside the frontier API layer. I don't think we need to turn that into a sweeping thesis today. The useful point is narrower. Open models are part of how countries and companies make capability less dependent on a small set of frontier API gates.
That also keeps the Nvidia release in perspective. An open-weight model from Nvidia can be exciting for builders without becoming the whole story. The question is what runs, under what license, on what hardware, with what quality, and whether the fallback is good enough for the workflow. When the answer is yes for even a slice of the product, the procurement conversation gets less brittle.
There are 3 supporting items I don't want to ignore, but I also don't want to overpack into one giant story. TechCrunch argues that AI-linked layoffs are becoming politically combustible as AI insiders accumulate large gains. We covered the evidence question around AI-cited job cuts on Sunday, so today's update is the public politics layer. If companies use AI as the reason for cuts, people will ask who captured the savings and whether the operational evidence exists.
That evidence question still matters. A company saying AI reduced headcount isn't the same as showing durable workflow change, persistent savings, and service quality that held up after the cuts. But the backlash doesn't wait for perfect data. It responds to a visible distribution, layoffs on one side, AI wealth and executive certainty on the other.
Then there are the misuse stories. TechMeme has the FBI and Google item about an AI-powered Chinese phishing operation. Al Jazeera reports on AI-generated sexualized imagery targeting Muslim women in India. Those aren't the same harm, and they shouldn't be flattened into generic deepfake discourse. One is law enforcement and platform takedown territory. The other is targeted, gendered, and religious abuse, with real people carrying the damage.
The implementation demands are different too. Phishing response asks about account infrastructure, takedowns, detection, and attribution. Image abuse asks about consent, reporting paths, search and platform distribution, local law, victim support, and whether removal processes work fast enough for the people being targeted. Calling both AI misuse is accurate, but not sufficient.
I can connect those stories without forcing them into one argument. Model capability is entering systems that already have power differences inside them. Vendor access depends on policy. Agents inherit runtime failures. Government guidance becomes purchasing and compliance work. Open models become contingency planning. Labor and abuse stories become public pressure on who benefits and who absorbs the risk.
And for builders, the next useful documents aren't only model cards. They are the fallback runbook, the procurement answer, the privacy boundary, the review log, and the abuse response path. If those don't exist, the product may still demo beautifully, but the first serious incident will ask questions the demo never had to answer.
So Monday leaves me with a sharper test for AI systems that want to be treated as infrastructure. Can the team show what happens when access changes, a tool lies by being too persuasive, a UI state contains secrets, a regulator asks for the process, or a harmed person needs the output removed? The answer to that test will decide more deployments than the next benchmark headline. Lenar Kess.